Differentiating Project-Based and Problem-Based Learning, Module 2 Application by Laura Salmon on September 1st, 2019. There are many similarities in both project-based and problem-based learning. They support active learning in the classroom. Both can powerfully engage students. They both meet the 21st century learning standards. They're both student-centered and provide exciting alternatives. They engage in real authentic tasks. They work in cooperative groups. They encourage the use of multiple sources, creative final projects, and teachers are the facilitators to the learning. Today, in our third grade science class, we will be using life cycles as our topic. Two different lessons will be shared, one using a project-based learning approach and the other a problem-based learning approach. Project-based learning begins with an end product, performance, or event in mind. Students follow steps like the engineering design process. A group of students will construct a 3D representation of a plant or animal life cycle in a shoebox. They will choose an animal or plant, research that organism's life cycle, and build a 3D representation using available materials. After explaining the end product to my students, I present the real-world problem. The local science museum is interested in adding a life cycles exhibit to their biology section. Our class has been hired to create three-dimensional models of a variety of life cycles to be put on display in the new exhibit. Students will be given materials to use throughout their project. They will be given sticky notes, craft sticks, cotton balls, modeling clay, aluminum foil, construction paper, glue, scissors, colored pencils, tape, a shoebox, pipe cleaners, and a computer to do their research on. Students are given a list of criteria and constraints. These will allow for the measurable outcomes. They include students are only allowed to use materials that are provided by the teacher. They must choose an organism from the list. Their final project must include labels, descriptions, and arrows pointing to the next stage and be in the correct order. The background in the shoebox must reflect the organism's environment. And students should be able to discuss the topics of birth, growth, reproduction, and death of their organism during the presentation. During the design step, students will list the steps of their plan and design for the challenge. They need to make sure to identify any scientific tools and other materials or technology used. Possible designs could include students building each stage from modeling clay or aluminum foil, as well as drawing and cutting out a picture of each stage on construction paper. Students will research the life cycle of their chosen organism. Students design and construct a 3D representation of their organism's life cycle, including labels and descriptions of the stages. Students may choose to alter their design or choice of materials throughout the building process in order to construct the best possible product. I, acting as the teacher, will walk around and facilitate and ask questions. Students will set up their presentations as a gallery walk. Students observing will pose questions on sticky notes beside each model. Students will choose 1 to 2 questions about their model to answer during the presentation. Each group will then present their life cycle model to the class, discussing how their model shows the birth, growth, reproduction, and death of their organism. Now we will be moving on to a problem-based learning approach with life cycles. Problem-based learning starts with an authentic real-world problem. Students work in cooperative groups. There are prescribed steps to follow, starting with presenting the problem. Students then define the problem. They discover what they know and what they need to know to solve the problem. They list possible solutions to the problem, revising if necessary, And finally, they share their findings and solutions with their peers. Students have been learning about the salmon life cycle. They know salmon move from freshwater to saltwater and back again. But there's a problem. There has been an accidental oil spill in the river. The students are going to work in environmental engineering teams to design a solution to clean this oil spill so that it has the least impact on the ecosystem. Then, students will define the problem together with their groups. Now students will work with their teams to come up with what they know about oil spills, ecosystems, and life cycles. Then they will come up with what they need to know about oil spills, ecosystems, and life cycles. Then they will begin to research. Using their research and what they know, they will generate possible solutions. Some students may build models that represent how things look, while others build models that represent the way something works. Students will be supplied with the following materials: vegetable oil, water, yarn, rubber bands, cotton balls, a sponge, paper filter, nylon, felt, a pipette, and a spoon. Students may also suggest other materials, and the teacher will provide them for them. As they're working, they may revise their solutions. The teacher will be walking around facilitating and asking questions. Students will share their findings and solutions through presentation. The group may choose a presentation tool of their choice to present their findings and solutions. While a team presents, the audience is writing down questions they have in their science journals. After the presentation, the team will call on the audience for questions. The team will need to answer questions on the spot. If they cannot answer the question right away, they will research the question at a later time. The audience will also evaluate the presentation using a pre-made rubric. The presenting team will also evaluate themselves. Project-based and problem-based learning have many similarities and differences, but overall, project-based and problem-based learning engages students and teaches them how to learn, but students have to become responsible for their own learning by participating in breaking old habits of past learning experiences, making a shift from being given the information to become active learners and develop self-regulation skills. This concludes my presentation of differentiating project-based learning and problem-based learning.